Hello everyone and welcome to the Fission Point JEE and NEET, and today we are going to discuss the NCERT solutions of electric fields and charges. We are continuing this. This is the second part in which we are going to discuss questions 9 to 16. The previous 8 questions were discussed in the part 1 or session 1. You can view it in our channel. So let's start with the question number 9 then. So this is the given diagram of question number 9, and we have been told to find the dipole moment as well as the total charge of the system. Also we have been given this charge is minus 1.5 into 10 to the power of minus 7 coulomb. I just confirm just a second. It is 2.5, I'm sorry. It is minus 2.5 and this is plus 2.5 into 10 power minus 7 coulomb. So first question is we have to find the dipole moment. For the second question, if you want to take a look at the net charge, so this is minus 2.5 into something and this is plus 2.5 into the same something. So the net charge of the system will be 0. So the answer to the second part of this question is 0, which is net charge. Now we come to the first part. So this is given, this is the y-axis, this is the x-axis, and this is the z-axis in this coordinate system. We have been given the coordinates of A and B. We have to find dipole moment. So for those who don't know, dipole moment represented by P vector is charge times distance. I'm sorry, charge is not a vector, but distance is a vector. So it is charge times distance between them. Charge must be equal to form a dipole, and in dipole moment questions you must be given equal charges. So we will only take the magnitude of the charge. I'll write like this here. You have to find the distance between them. So if you look closely, the distance between this and this point, if you take this as origin, it is 0, 0, 0. Distance between these 2 points, or the A charge at the origin, is 15 centimeters. And the distance between the origin and B point is 15 centimeters. We can directly add these up because this is in a one straight line. This is the z axis, one is here, one is here. 15 centimeters from the origin and again 15 centimeters from the origin. So we can directly add these up and write it as 30 centimeters or 0.3 meters in SI units. So we will write here 2.5 times 10 to the power of minus 7 times 0.3. So this will come up to be 0.75, I guess, yeah, into 10 power minus 7, or 7.5 into 10 power minus 8 coulombs. Oh no, sorry, the unit is coulomb meter. You see, this is in coulomb and the distance is in meter, so the unit will be coulomb meters. So this and these two are the answers of the 9th question. Now we'll move on to the 10th question. Here is the diagram for the 10th question. There is a dipole here. We'll assume it as an ideal dipole. There is no need of that too. And it is kept in an electric field of magnitude 5 to 10 to the power 4 Newton per coulomb. And it is given that the dipole moment of this dipole is 4 in 10 power minus 9 coulomb meter. And we have to tell the torque acting on the system. Torque acting on the system. We just have to tell the magnitude of torque. So for those who don't know, the formula for torque in these types of situation is P vector cross E vector. If you want a detailed derivation for this, ask in the comments and I will provide you with it in the next video. And so we just have to find the magnitude. So I will write magnitude or mod here, and cross product on magnitude becomes sine theta, where theta is the angle between these two parameters, that is dipole moment and electric field, which is given to be 30 degrees in the question. So now we will just simply multiply these. 10 to the power minus 9, 5 into 10 to the power of 4 into sine 30 degrees. Sine 30 degrees is half. So this will come out to be, I will write it there, hope it is visible here. I will write it here, 5 into 4 is 20 into 10 to the power of, I will write tau. If I am writing it without the vector sign, assume it to be magnitude, okay. 4 into 5 is 20 and this will come out 10 power minus 5 into half. So this will be equal to 10 into 10 to the power of minus 5 or 10 to the power of minus 4. And since this is tau, it will be in Newton meters. Hope it is visible here. I'll just see if it is visible. Yeah, it is visible here. So the answer, the final answer for torque is 10 to the power minus 4 Newton meters. Now we'll move on to the 11th question. This is the 11th question. Yeah, it is the 11th question here, and I have drawn the diagram. This is a polyethylene and it is a wool piece or a wool cloth, and it is given in the question that when these two are rubbed together, then the polythene will attain a negative charge of 3 into 10 power minus 7 coulomb, and now we have to find the number of electrons transferred, and we have to tell if there is any mass transfer or not. So first we will do the part A, number of electrons transferred. For those who don't know, when wool is rubbed with polythene, the wool attains a positive charge and the polythene attains a negative charge. This is not its nose, this is a negative charge, and this is because electrons are transferred from wool to the polythene cloth, disturbing the neutrality. I have told about this in the previous video in detail. You can go and check it out. Okay, so first number of electrons transferred is asked, so we will apply quantization of charge. N is the number of electrons transferred, so we want it. So we will transpose this here, Q divided by E. E is the charge on fundamental particle, which is a constant. So we will write this as minus 3 into 10 power minus 7. If you want, you can just take the mod, or yeah, I will just take the mod here, because we know number of electrons transferred is positive in this case. 1.6 into 10 power minus 19 coulomb is charge on fundamental particle or charge on electron. So N will come out here to be 3 divided by 1.6. I will just do this really quick. Okay. So this will come out to be 1.87 into 10 to the power. I took 1 0 from here, so 8 and minus 8 plus 19, so this will become 11, 10 to the power of 11. No, I did not take one from here, so this will become 10 to the power of 12. These are the number of electrons transferred. You can do the math here. This will come out to be this, and the second part is asked to us that is there any mass transfer. So in most of the questions we assume the mass of electrons to be negligible in chemistry, as you have studied in class 11th chapter 2, structure of the atom. But here there will be some mass transfer because there is transfer of electrons. So these many electrons are transferred, so the mass transferred will be mass of each electrons times the number of electrons. So we will write mass transfer will be equal to N, means number of electrons, into mass of each electron. First of all, the answer is yes. They have asked if the mass transfer will occur or not. So we will multiply this number 1.87 into 10 to the power of 12 into mass of an electron, that is 9.1 into 10 to the power of minus 31 kg. So the answer will come in kg because this is unitless, it's just a number. So we will multiply this really quick here. So this will come out to be 17017, 2 points here and 1 point here. So this will come out to be 17.017 times 10 to the power of, when we subtract these, 31 minus 12, it will become minus 19 kg. If your answer is in gram, you can convert it any further. This is the final answer, 17.017. I'm very sorry for any calculation errors. We'll just check the answer here quick from the textbook. Yeah, so they have taken a little bit more of this value here. And yeah, that's it for the 11th question. Now we'll move on to the 12th question. Here we are in the question number 12. There are two parts in this question as well. So the first part is asking that there are two spheres, each with a positive charge of 6.5 10 power minus 7 coulombs, separated by 50 centimeters or 0.5 meters, and their radius is negligible when compared to the distance between them. When someone tells you this means that you have to take these spheres as point charges, you have to assume them as point charges, and force between them is asked, force of repulsion. So force is force of repulsion because you have the positive charges. So we'll apply the formula F equals to K Q1 Q2 by R squared. That will be 9 into 10 to the power of 9 into 6.5 into 10 power minus 7 squared, because there are two of them with the same charge, divided by 0.5 squared. So this will come out to be 1.52 into 10 to the power of minus 2 Newton. I'll just check the answer, just a minute. Yeah, this will come out to be this. You can calculate it later. Okay, and in the second part it is asked to us that what will happen to the force if the charge is doubled and the distance between them is halved. Okay. Yeah, force of repulsion if charge is doubled and distance between them is half. So we'll calculate it here on the side. Let the force between them before this force itself be F. The value of F is KQ square by R square. Why Q square? Because they are of same charges. So Q1 into Q2 will be equal to Q squared. And now F dash be the new force between these two. If the charge is doubled, let the charge be 2q and it will be squared as well, and distance is half, so it will be r by 2 squared. So the new force will become k, 2 squared is 4, so I will write 4 here, q squared by r by 2, so it will be r squared by 4, and this 4 will go up in the numerator, so it will become 6t. So remember this value, we assumed it as here, and we can put it back here, so it will be equal to 16f. F dash will be equal to 16 times of f. So the force will increase by 16 times. You can multiply this number by 16 times, and then your final answer will come that what will happen to the force. Okay, you can do similar types of questions in this similar fashion. We'll move on to the 13th question next. So the 13th question is somewhat similar to the 12th question. They have asked, what if these two spheres, along with them, there is a third uncharged sphere which is first touched to this, then it is touched to this, and then it is removed from the whole system, and then what will be the new force between these two both? So there is a third wheeler here, and we'll assume this value to be q. So let this be sphere A, let this be sphere B, and the uncharged new sphere be sphere C. So when these two are connected, a process of conduction will happen which will distribute the charge in these both. These both are told to have equal dimensions. So this is why we can do this, otherwise they will have the same potential, not same charges always. So sphere A will have a A by 2 charge, sphere C will have a Q by 2 charge. Okay, so now from uncharged, this will become charged, and these both will have equal charges. Now it has told us that B and C are touched again. So we'll keep this here, and B and C are touched again. So what will happen is the charge between both will distribute, or the charge will flow until the charge in both is same, or you can say the new charge in both will be average of these two charges. So how to calculate average? We will add both the charges, divide them by 2 because there are two spheres. So this will come out to be 3q by 4 in each of them. Okay, so new charge on C is 3q by 4, new charge on B is 3q by 4, because the charge in B and C has to be equal if they are touched together and if they are of the same dimension. So now what they have told is they remove C afterwards. So I will remove the C from here. And now what is the new force between A and D? So don't plug in the values directly, we will just solve this first. We will write new force as K Q1. What is Q1? The charge on A is Q by 2 and Q2 3Q by 4. I will remove this right now on A and B, dividing by the distance between them, which is constant from earlier, 0.5 meters, or I'll write 0.5, or we will instead write r squared because we know the old value, so we will try to attain it again, so we don't have to calculate so much. So first solve the extra parts first. This is 3 divided by 2 into 4, 8. So this will be 3 by 8 kq squared by r squared, and let me write this as force new, because force new will be equal to 3 by 8 force old. What is the old force? That is 1.52 into 10 to the power of minus 2, which we calculated in the last question. So if I plug in the value 1.52 into 10 to the power of minus 2, this will make a new force. So this is the concept of conduction here, and you can calculate this value and find the new force. So now let us go to question number 14. Okay, so this is the question number 13, I guess. I'm sorry, it's question number 14. And in this question, a diagram like something like this is given, and these are three charged particles 1, 2 and 3, and what is asked is what is the nature of their charge, means what is the polarity, and which charge has the highest charge to mass ratio. So this will be somewhat similar to the J.J. Thomson's cathode ray experiment, which was taught in class 11 chapter 2 structure of the atom. So you can see there, and if you want more detailed explanation, you can ask to me in the comments. So first I will tell you about the nature of the charges. So as you know that opposite charges attract each other, and these charges were moving first in a straight path, but these two charges were attracted towards the positive plate. That means they are negative on their own, because positive and negative attract each other, right? And this charge is attracted to the negative plate, so this charge must be positive in its nature, by its own. Okay. And then the second question, which has the highest charge to mass ratio, Q by M ratio. So the Q by M ratio is directly proportional to deflection in electric field, which here is created by the plates. So the charge which has deflected the highest will have the highest charge to mass ratio. In textbook it is not very clear, but the charge 3 has deflected most from its path. So the charge 3 will have the highest charge to mass ratio, and so the answer is negative, negative, positive and charge 3. Next we'll move on to the 15th question. So this is the 15th question and the part A of it specifically. Here there is a coordinate system x, y and z, and there is a plane here. I guess it is looking like a plane, yeah. And there is an electric field going in the I cap direction, which is the positive x axis, which value is 3 into 10 to the power of 3 Newton per Coulomb. And there is a plane here. The area of the plane is not given, but the length of the side is given. This is a square plane. The length of a side is 10 centimeters, so all its side will be equal. We mark it like this. If we mark all the sides with a single line or double lines, but all the sides with the same type of lines, then these sides are same. Okay, this is just a notation, and so we have to find the flux through the plane. So our teacher, means whom I study from, has told us to look as electric field or flux as bullets, and how many of those bullets rip through your chest, or you can say rip through the shield that you are holding. Those are flux, which are perpendicular to your shield are flux. See this, for example, these lines are perpendicular to the plane, so this is flux. Okay, now since it is a sheet, its area vector can be this side or this side. We will not assume that, we will just simply apply the formula. Flux equals to E A cos theta, or E dot A you can write cos theta, and here the angle between electric field and the area vector is either 0 degree or 90 degrees, 180 degrees, because you see the area vector can be projected like here, or it can be projected like here. For a 2D surface it can be projected in any directions, just perpendicular to the plane. It must be perpendicular to the plane. So I will take cos theta to be 0 for now. So this will be E into A, which will be equals to 3 into 10 to the power of 3. The area of square is A squared, so this is 10 centimeter. I will write as 0.1 meters and will square it. So this is 10 to the power of minus 1. The square will be 10 to the power minus 2. So this will come out to be 30. And remember, flux is just a number, so there is no unit of it. So the final answer for you is 30. Now we'll move on to the part B. So we have come to this question. This is the part B of the question, in which it is given the same plane is rotated to a 60 degree with the coordinate axis, or you can say 60, to make an angle of 60 degree with the electric field. Since electric field is in I cap, so it is parallel to the coordinate axis. So this is the final diagram of it, and flux can be seen here as E dot A cos theta. I'm just taking the value, no dot product. So this will be 3 times 10 to the power of 3 into this is the same plane, so it will be 0.1 squared into cos 60 degrees, since it makes an angle of 60 degree here. So we will write this as 30, what this came before, we just calculated it, into cos 60 degree is half, so this will be 15. Now I just said that flux is just a number, so it does not have any unit. Well, you can also say that it has a unit Newton meter square per coulomb. You can write as both. In some books it is given that it is just the number of perpendicular electric field passing through an area. So you know a number has no unit, but this is the unit from its formula. So you can also write it like this. Okay. This is the 15th question. Now we move on to the last 16th question. This is the 16th question and the last question for today's session. So this is the same thing here from the last question. They have just said that instead of the square you have taken a cube of side 20 centimeters. This is the length of the side of cube, which we call A sometimes. You can call it anything you want. So what is asked is, what is flux through the sides which are parallel to the coordinate system? I will show you a cube here, and let me demonstrate what it is trying to say. Right here there is a cube here, and when it says coordinate system, parallel to coordinate system, it means that it should be parallel to the electric field going. Okay, so electric field is this side, and this is the main coordinate system we will take right now. Or it means to say that you have to find flux in the faces of this cube which are parallel to the electric field. So if electric field is going this side, they mean this face, the top face. Assume this is your room, so this is talking about ceiling of the room according to this diagram, and also one more parallel, which is floor of your room. So the question is talking about these two sides. You can neglect all the sides. They are not parallel to this coordinate system, they are perpendicular to it. As you might know, all the three coordinate systems are perpendicular to each other. So it is asking to this and this. So now through these two things flux will not pass through, or a flux will not be made. Electric field will just touch and go from it. If you can imagine, as our teacher taught us, I told you about the shield thing. If you hold a shield like this, it can block a bullet since it will become perpendicular to it. But if you hold your shield like this, the bullet will go through it without any deflection, or you can say without stopping the bullet. So flux through here will be zero, and I'll explain you through the formula as well. We write flux equals EA cos theta, and here you see the angle between E and the area vector. You see the area vector is here. The angle between, I'm so sorry, there was some technical glitch, we'll continue. The angle between E and area vector, as we were talking about, is 90 degrees. And as you know, cos 90, that is angle between E and A, that is cos 90 is 0 if you have studied trigonometry. So this will be E into A into 0, so this whole thing will become 0. Some books or textbooks even tell that the flux entering through it is flux exiting through it. It is absolutely correct, because no flux will remain inside, and thus the flux of this body will be 0. Here too the thing is the same, and thus flux entering it is equal to flux exiting it, because we have to find the flux in the parallel sides of the cube, and thus flux here is 0. So that's it for today's session. Hope you enjoyed it. Please like and subscribe to support me. Thank you so much.